Okay, in this video we're going to be solving trigonometric equations, and I thought we'd just jump right into a couple of examples here. For this first example, we're asked to solve on this interval. That is, we want to find an angle theta that's greater than or equal to 0 but also less than 2 pi. Okay, now we want sine of 3 theta to be equal to -1. Now first of all, if somebody asked you, okay, and they wrote sine of something equals -1, well, you'd know that whatever went right there, right, the sine of the something, well, one option is 3 pi over 2, right, because sine of 3 pi over 2 equals -1. And we're in the same predicament over here. So what's in parentheses, the 3 theta, one possibility is that 3 theta equals let me see if I can write a theta better than that. So we've got 3 theta equals 3 pi over 2. Now the reason I said that's only one possibility is because 3 pi over 2, well, we know that sine of 3 pi over 2 is equal to -1. But what happens if you increase this angle, 3 pi over 2, by let's say 2 pi? Aren't you back to the same place on the y-axis? So what if you increase it by 2 pi or 4 pi or 6 pi? Or what if you subtract 2 pi or subtract 4 pi? So what we're finding is that this isn't the only possibility, right? 3 theta, well, it could be 3 pi over 2, but it could also be that you could add to that any integer multiple of 2 pi. And we write that in the following way: k 2 pi, where k is an integer. So k is an integer. So in other words, this could be plus 1 times 2 pi, or plus 2 times 2 pi, or plus 3 times 2 pi, or the k could even be like -3, right? So it could be 3 pi over 2 minus 6 pi, and that would still bring you to the same place on the y-axis, such that sine of that is again equal to -1. Okay, now notice the problem said solve for theta. Okay, we haven't solved for theta yet. We have to get theta by itself. And what we're going to do now is we're going to divide by 3. So we're going to take this equation and divide by 3. Now dividing by 3, of course, is the same thing as multiplying by a third. So let's take this right hand side and we'll write times 1 over 3. Okay, so this left hand side is just theta, and then when you distribute this 1/3, well, the 3's are going to cancel, right? So you're going to have pi over 2 plus, well, it's going to be k2 pi divided by 3. So let's write that as k times 2 pi over 3. Okay, now k is still what we said before, right? K is still an integer. And so what we're going to do now is we're going to think about the possibilities of k or the possible values of k for which the angle theta is still between 0 and 2 pi. So what are some possible choices? Well, k could be 0, and if k is 0, well, 0 times 2 pi over 3, that leaves you with what? Well, theta is equal to pi over 2. Now, does that work? Sure, right? Because pi over 2 is between 0 and 2 pi. So try another k. Let's try k is equal to 1. Now remember, k has to be an integer, right? That's what we said. Well, when k is 1, you get theta is pi over 2 plus what? Plus now, well, it's 1 times 2 pi over 3, which is just 2 pi over 3. And when you add those together, what do you get? Well, you have to get a common denominator, so it's going to be 6. So it's going to be 3 pi over 6, right? Plus, and this is going to be top and bottom by 2, 4 pi over 6. And so when you add those together, you get 7 pi over 6. Now the question is that a possible value for k, or for theta? So sure, right? Because 7 pi over 6 again is between 0 and 2 pi. So far I have two solutions, right? Pi over 2 is one of them. 7 pi over 6 is another. Maybe other values of k will work. Let's try another one. Let's go on to k is equal to, how about 2? So when k is 2, what do I get? Well, I still have my pi over 2, right? And now I'm going to add plus 2 times 2 pi over 3. So plus 2 times 2 pi over 3. And what does this end up being? Well, this is pi over 2 plus, well, 4 pi over 3. And then getting a common denominator, we're looking at 3 pi over 6 plus, well, this is going to be 8 pi over 6. And that brings us to 11 pi over 6. So once again, we have a new value of theta, right? 11 pi over 6. And the question you have to ask yourself is that theta between 0 and 2 pi? And the answer is yes, because 2 pi is 12 pi over 6, and this is a little less than 12 pi over 6. Now notice if you go one more value, if you go k is equal to 3, for example, you get, well, it's going to be pi over 2 plus 3 times 2 pi over 3. And that's going to be pi over 2 plus, well, let's see, the 3's are going to cancel, right? So plus 2 pi, and that ends up being 3 pi over 6 plus, well, it's going to be 12 pi over 6, which is 15 pi over 6. Okay. Now you could see at this stage, right, that pi over 2 plus 2 pi is clearly greater than 2 pi. Or you look at 15 pi over 6 and you see that, again, that's greater than 2 pi. In other words, this value of k doesn't work. So we found that k equals 0, k equals 1, and k equals 2. They all worked, right? They gave us thetas that worked. Theta is pi over 2. That's one possibility. Another possibility, theta is 7 pi over 6. And a third possibility, theta is 11 pi over 6. But once you get above k equals 2, no longer do you find angles that work. Now, in future problems, keep in mind that, well, k is an integer, but integers, aren't just 0, 1, 2, and 3, and so on. And the positive integers, you can also have k equals -1 and -2 and -3. Now, if you plug in -1 here, it's going to be 3 pi over 6 take away 4 pi over 6, and that would be negative pi over 6, which is less than 0. Okay, so I didn't bother with k being negative, but keep in mind that in future problems it can be. Okay, so let's go ahead and see what exactly we're talking about here. We have three solutions, right? Pi over 2, 7 pi over 6, and 11 pi over 6. Let's write those on another sheet here. So pi over 2, 7 pi over 6, and 11 pi over 6. So we said pi over 2, 7 pi over 6, and 11 pi over 6. Okay, so these were solutions to our original problem, right? Our original problem was, keep in mind, it was sine of 3 theta equals -1. Okay, so if we think about that for a second, right? Sine of 3 theta is equal to -1. Now, sine of 3 theta is a function, right? You can actually graph that function. You can actually graph y is equal to sine of 3 theta. And so we know how to graph this, right? Because all this is a sine function where the period has been changed. And the way we do that is we, first let 3 theta be equal to 0, and then we let 3 theta be equal to 2 pi. And then we divide both sides by 3. So we get theta is equal to 0. And then over here we get, dividing both sides by 3, we get theta is equal to 2 pi over 3. Now we then take the right end point of the interval, which is 2 pi over 3, and then subtract the left end point, which is 0, and then divide by 4. Now that's, of course, the same thing as taking 2 pi over 3, and well, dividing by 4, which is 4 over 1, which of course is taking 2 pi over 3, and multiplying by 1 over 4, and that leaves us with, well, the 2's cancel across, and that leaves us with pi over 6. Now what this is, remember, when we graph, that refers to what I call the step size. Now the step size is the length of the subinterval that you get when you take the interval from 0 to 2 pi over 3 and you divide it into 4 pieces. Okay? So we're going to graph this function y equals sine of 3 theta, and we're going to interpret exactly what the solutions to this equation meant. Sine of 3 theta equals -1. Okay, so let's do that now, keeping in mind our step size. Okay, so we're graphing y equals sine of 3 theta. And our step size, remember, is our step size from the previous page was pi over 6. And so what are we doing? Well, we're starting at 0 here, and we said that we had to go up to 2 pi over 3, right? So we complete a full sine wave from 0 to 2 pi over 3. And what I've done is I've graphed, well, we're going to get one wave here, and then when we go up to another 2 pi over 3, that is 8 pi over 6, we'll get a second wave, that is a second cycle, and then finally up to 12 pi over 6 to get a third cycle of sine. Now the step size is pi over 6, which is why I chose to subdivide or to create these subintervals, right, of length pi over 6. Okay, let's go ahead and graph this function. So we go through that point, we're at pi over 6, we're at 1, we're there. At 3 pi over 6, we're -1. At 2 pi over 3, we're back to 0. And then we'll see, we're up to 1 again, 0. So I'm in my second cycle, right? So -1, 0, +1 again, 0, -1 here. And then we're completing our last cycle of sine. Okay, let's go ahead and graph 3 sine waves now. Okay, using this fancy tool. So I'm just making sure that the concavity is right? We want it to look like a sine wave. So right now it's going to be concave up, right, through these points. And concave down there, right, like a wave. And of course, I could do this by hand, but I find that this tool is a lot nicer. It just makes it look more realistic, like an actual sine curve. Let's bend that a little bit. Come back to that one. Okay, this one's going to need a little bit of tweaking. Okay, so what we'll go ahead and do now is we'll go ahead and fill that in with an actual curve. Okay, and there we go. So we have 3 cycles of sine, right? The first cycle, the second cycle, and then the third cycle. Now, you should know that this isn't quite vertical here. This should look more like that, right? So it's not quite vertical there. So maybe something more like that. Okay, so let's go ahead and interpret our solutions now. What we were doing is we were solving the equation sine of 3 theta equals -1, okay? And this is the graph of sine of 3 theta. Do you see where this curve takes on the value of -1? Right here, right? That's our first value, and notice that that's pi over 2. That's our first solution. Right here, which is 7 pi over 6. And then finally our last solution, which we got earlier, which was 11 pi over 6. So when we graph this function sine of 3 theta and we set it equal to -1, we should be able to see from the graph, we should be able to see our solutions from the graph. And notice that these are the values of theta, right, for which sine of 3 theta equals -1, but also where theta lies between 0 and 2 pi. Okay, so that problem we saw solutions of that problem from different perspectives, and that's often helpful when you're solving trigonometric equations. Okay, let's try another one now. Okay, let's say we want to solve again on the interval 0 to 2 pi, secant of 3 theta is equal to -2. Okay, I wanted to do this one because instead of thinking about secant, I often like to think about cosine. Now, if secant of this angle, that is right, secant of all this is -2, then it must be true that cosine of the same thing, right, must be equal to, well, cosine and secant are reciprocals, right? So cosine of the whole thing must be, well, the reciprocal of -2, which is -1/2. And then I want to think to myself, well, when is cosine of something equal to -1/2? And if you need to, you can go back to the unit circle to think about this. So if we think about the unit circle, and we say, okay, when is cosine of something equal to -1/2? Well, when is cosine negative? Well, quadrant 1, 2, 3, or 4. Well, cosine is negative in quadrants 2 and quadrants 3, right? And remember, cosine on a unit circle refers to the x-coordinate. And so the x-coordinate is pretty small. So because I'm comparing basically 1/2 and √3/2, and I know 1/2 is smaller than √3/2. So I want to create a pretty large reference angle here, right? So I come up here and I draw my reference angle, and for this reference angle I know that the x-coordinate is small. So this angle, now this is a large reference angle, right? So that would be our angle pi over 3, which makes this angle, as we know, makes that angle 2 pi over 3. Okay? But there's another place where cosine is -1/2, and that would be for this angle. So again, I want to draw another large reference angle in here. And then now I'm thinking about the second possibility, which is that angle. Okay? And if I think of this, if I know this is a reference angle of pi over 3 again, that makes that larger angle 4 pi over 3. So I can see that cosine of both 2 pi over 3 and 4 pi over 3 give me -1/2. So I come back to my original problem and I said, okay, those are two possible angles, right? Those angles would be, here, this would be either 2 pi over 3, right? Or the other possibility was 4 pi over 3. Now I'm not going to go ahead, of course, and say that those are values of theta. That is cosine of what's here in the parentheses, right? So this whole thing, 3 theta over 2, well, it's either equal to 2 pi over 3, right? And again, plus any integer multiple of 2 pi for the same reasons as earlier. That's one possibility. And the other possibility is, let's see, well, it's going to be 3 theta over 2 equals 4 pi over 3, plus again an integer multiple of 2 pi. Okay, so I have to solve both of these equations for theta. And what I'm going to do again is I'm going to multiply both sides by the fraction, right? So it's going to be 2/3 and I did that so that I could cancel the 2/3 there. So let's do the same thing over here. 2/3, and let's multiply both sides of this by 2/3. And let's distribute that 2/3. So on the left-hand side I get theta, and on the right-hand side it's going to be, let's see, well, it's 4 pi over 9 plus, well, k times 4 pi over 3. And then here, the 3's cancel and the 2's cancel. So we get theta is equal to, well, it's going to be, let's see, 8 pi over 9 plus k times 4 pi over 3. Okay, now k, once again, these are possible integer values, right? So I'm going to scroll through my list again. So let's try k is equal to 0. And if k is 0, what do we get? Well, we get 4 pi over 9 plus, now let's write this in terms of, well, actually k is 0, right? So that's just 0. So that's one solution, 4 pi over 9. Why? Because 4 pi over 9 lies between 0 and 2 pi. Okay, let's try another one. How about when k is 1? Well, we're going to have the 4 pi over 9 again. And now let's go ahead and write this. This is going to be 1 times 4 pi over 3, right? But when you multiply top and bottom by 3 to get a common denominator, that's going to be 12 pi over 9. And when you add those together, you're going to get, well, that's equal to 16 pi over 9. And we just barely made it, right? Because 16 pi over 9 is a little less than 18 pi over 9. And 18 pi over 9 would be 2 pi. So we have one solution right here, 4 pi over 9. And we have a second solution, 16 pi over 9. Okay, are there any other solutions? Now, you have to check this out, right? So k is equal to 0. Well, that gives you the 8 pi over 9. So that certainly works. That's certainly between 0 and 2 pi. And then you try k is equal to 1. And that brings you to 8 pi over 9 plus, well, it's going to be 1, right? And then, just like before, you're going to get plus 12 pi over 9. And what we see when we add those together is we get 20 pi over 9. Now, 20 pi over 9, of course, is too much because it exceeds 18 pi over 9, which is 2 pi. So this does not give us a solution. So our third solution is 8 pi over 9. So your solution set would be 4 pi over 9, 8 pi over 9, right? And the final one is 16 pi over 9. And this would be your answer. Now what you could do, of course, is just to confirm graphically is you could go ahead and graph y equals secant of 3 theta over 2 and find indeed, look for where that's equal to negative 2, look for the angles between 0 and 2 pi, and you'll find that you get these three angles, 4 pi over 9, 8 pi over 9, and 16 pi over 9. Okay? So those are some examples of how to solve trigonometric equations. Hope that helped.